Okay, so today, ladies and gentlemen, we got our quiz. We're going to do that right away. We'll give you 25 minutes to get that done. Okay? After that, we will go back and talk a little bit more about volume 2 mole stoichiometry, and then we will do a worksheet packet. Now, there is something that you need to take care of by the end of the day, Tuesday, ladies and gentlemen. So in Canvas, in the classroom, there is an announcement for you. So under announcements, there is a survey that the district has asked us to give all science students. So if you go to this survey in announcements, there is a link to the survey. You can take it. It's a Google form survey. It's about the class that you are taking right now. So there are a number of questions you have to answer. The weird part about it is it's set up for any science class that a student may be taking. So since you're taking chemistry, you're going to do everything based on the questions for chemistry class. You do not have to do them based on biology, based on physics and things like that. So for a lot of the questions, the survey, you're going to have to put not at all, because you're not taking that class. Okay? So you answer the questions based on any science classes that you may be taking this year. Okay? So it'll ask you a question like, what do you think of the book that we use? That's an easy question for you. You can put down, we don't use it. All right? I don't think any of you have cracked the book open for this class all year. I've never given you one, and we don't use one. Okay? So any questions about the resource, you can put not at all for this class because we don't use one. Okay? So you need to get that done at some point between now and next week, Tuesday. So after your quiz, you can take your computer out, you can open it up, you can work on that survey. If you have trouble getting to it or anything, please let me know and I will find another way of getting it to you. Are there any questions before we take our quiz today? Okay. Please remember, by the end of the day today, any missing work for Unit 6 needs to be turned in. So if you're missing any labs, they got to be in by the end of the day today, 3:15. When you're done with your quiz, bring it up, set it on my desk, ladies and gentlemen. Please remember, too, we are out of class a little bit earlier today. You get out at 8:34 because we're extending the advisory period today because you're taking a survey in there. So apparently it's survey season, ladies and gentlemen. Okay? All right. If you have any questions when I hand out the quiz, please raise your hand. I'll be happy to come over and assist you with them. Otherwise, ladies and gentlemen, go to work.
Bless you.
Okay.
Bless you. Again. Yes, sir. You're welcome. Is this binary? Is this a binary compound? Are these all binary compounds? They could be, or they could be ternary. You need to know that. The ending tells you that. What? Is not one of the endings that change. It's a compound. If it ends one way, it is binary. If it ends another way, it is ternary. there anyone still working on the quiz? All right, ladies and gentlemen, let's take a look at a problem here then. This is a problem like we were doing yesterday. Okay? If 785.7 milliliters of dinitrogen trioxide gas at 12.6 psi and 44.4 degrees Celsius is mixed with excess liquid water, how many grams of nitrous acid will be produced? Okay, so ladies and gentlemen, again, this is a problem like we have been doing, and you're going to hear me say that over and over again in this unit. We need to write a balanced equation for this particular problem. Now, this is not a single replacement. This is not a double replacement, ladies and gentlemen. This is actually a synthesis reaction. So I'm giving you all of the reactants, and I'm giving you what the product is. Your reactants are dinitrogen trioxide gas and water. Your product is nitrous acid. So we need to write a formula for that. So that is how we are going to begin this problem, ladies and gentlemen. All right. Enter full screen, exit full screen. Sorry. All right. Okay, dinitrogen trioxide. Elsa, how do we write dinitrogen trioxide? Yep. Perfect. This is a covalent compound. Covalent compound, they give you everything in the name. Di means 2 nitrogen, N2. Tri means 3 oxygen, N2O3, ladies and gentlemen. Okay? Okay, it is a gas, so we can put a G by it. Is mixed with excess liquid water. Linda, water. What state? Yep, put an L by it. Told you that in the problem. Okay? Now the hard part. We are going to produce nitrous acid. Now, binary or ternary acid, Jesus? Okay? Named off of a polyatomic, correct? What polyatomic is the basis for nitrous acid? Nitrate. Nitrite. ITE ending. OUS acids come from an ITE ending. IC acids come from an ATE ending. Remember, we've already established that it is ternary because the name does not begin with hydro. So give me the formula for nitrite. Okay, so let's put hydrogen with it. What's the charge of hydrogen?
1 + 1.
What's the charge of nitrite?
-1.
So what do we do to this formula?
Leave it.
Leave it. Nothing. There is nothing to change here other than I'm going to move this H closer to the NO2. +1 and a -1 means it's going to be this. Now we do need to do one thing to this to make it an acid. AQ. All right. So now, ladies and gentlemen, let's do our balancing. NOH. 2 nitrogen over here, 1 over here. 3 oxygens here, 1 oxygen here for a total of 4. 2 oxygens here on the other side. 2 hydrogens here, 1 here, ladies and gentlemen. All right. Boy, it doesn't get any easier for balancing this, does it? What do we do? Put a 2 in front of the nitrous acid. Okay, that doubles everything over here. And boom, everything is balanced. One shot, everything is balanced. Any questions on that? Okay, so now, ladies and gentlemen, my suggestion to you is always to do this. Take and write down what you're given, write down what you are looking for. So we are given 785.7 milliliters of the dinitrogen trioxide. It is at 12.6 psi, and the temperature is 44.4 degrees Celsius. Okay? By the way, what is that setting up for you to use? PV equals nRT. Perfect. And what do they want you to solve for? Grams of nitrous acid. So we are looking for grams of that. So again, you said it, Denia. We are going to have to use PV equals nRT. Now, this is not a conversion factor, but we are still doing the first step of our process, which is take what we're given and get it into moles. We are doing it through the formula for ideal gas law of PV equals nRT. So we are going to take and we are going to substitute in our pressure, 12.6 psi. We are going to substitute in our volume, but what do I need to do to that volume first? Convert it to liters. So that becomes 0.7857 liters. Okay? That is equal to N. And we are going to leave. N is number of moles. That is what we are trying to find. What do I use for an R value here, ladies and gentlemen? But what is the number? 1.21. That should still be handy on your periodic table from the last unit, ladies and gentlemen. Okay, and then what do I do with my temperature? Turn it into Kelvin, which becomes what? Okay, so again, I'm still taking what I'm giving and I'm getting it into moles. To do that, ladies and gentlemen, I'm going to take this side where the N is, and I'm going to divide it by the two things I was supposed to multiply it by. What I do to one side of the equation, I'm going to do to the other. Okay, again, going back and canceling out the things that cancel out. This entire factor and this entire factor cancel out on this side, leaving me N alone. Over here, the unit of PSI cancel, the unit of liters cancel, and the unit of Kelvin cancel. I am left with the unit of moles. So I need someone to please take and tell me what N equals when you do the math here. 0.026. Is that the last digit as well?
No, it's 0.0257.
Okay, let's do all three of those because, again, that gives me 3 sig figs. And that's moles of HNO2. Now you've done the first part of your problem. Yes, it's a little bit more work to do PV equals nRT, but it is not difficult to do PV equals nRT. That is what we did entirely in the last unit. I'm not asking you to remember that the density of gas A over the density of gas B, all that stuff. We are just using PV equals nRT from the last unit. So now, ladies and gentlemen, now we can go into setting this up as a conversion factor. So now we do 0.0257 moles of HNO2. The next step, ladies and gentlemen, is your ratio step. Your ratio step involves what you are in and what you are going to. So what goes on top of this fraction here, Madison? What goes on top of it? Of what? I agree with the HNO2, but not 1 mole. How many? Look at your balanced chemical equation. See the 2 out in front?
Oh, 2.
Makes a big difference. Going to make a big difference in your problem. 2 moles of HNO2. By the way, I have this labeled incorrectly. I think somebody was about to tell me that. I have this labeled incorrectly here, ladies and gentlemen. I'm sorry about that. We were not finding HNO2 there. We were finding N2O3. That is my mistake. Which means this here, I'm sorry, is NO2, N2O3. My mistake on labeling. What goes on the bottom here, ladies and gentlemen? What goes on the bottom of this fraction, Giselle?
1 mole. And 2O3.
Perfect. What you are in goes on the bottom. This is what you are in. There is no coefficient in front. Therefore, that is a 1. This is what you are going to. There is a 2 in front, so we put a 2 moles HNO2. This is the only place that we worry about the numbers that are out in front. The only place. We don't worry about it in this calculation. We don't worry about it in our formula mass calculation. That's it. That's the one place where we worry about it is in this step right here. So now we've taken what we've given, we've got it into moles. We've used the molar ratio to go from moles of reactant to moles of product in this case. What's the last step? What is the last thing that we do here, Ethan? What step are we on? Okay, please pay attention. What step are we on, Morgan? Okay. All right, let's see. Wendy, what step are we on?
Right now? Or
Yep. Well, of these 3, how many have we done? So which step are we on?
3.
Okay, good. That's what I was hoping for. That's what I was hoping for. So what are we going to try to do? We have to get our answer into grams. So we are going to use the formula mass. Yes, thank you. So to get to formula mass, ladies and gentlemen, we put 1 mole of HNO2 on the bottom. Now on the top, I need somebody to take a calculator and add 1.008 plus 14.007 plus 2 times 15.999. 47.013. Thank you. And that's grams of HNO2. Okay? Let's check and see if we got everything canceled. Moles of N2O3 have canceled. Moles of HNO2 have canceled. We are left with grams of HNO2. Now, for your math, 0.0257 times 2 times 47.013. Nothing on the bottom to worry about here.
2.416.
What is it?
2.416.
2, all right, 0.416.
Yep.
So 2.42. 3 sig figs. Why? Pressure and temperature limit you down to 3 sig figs. Questions? Yes, no, maybe so. In all of these problems, ladies and gentlemen, we are doing the same 3 steps over and over and over again. Take what you're given, get it into moles. Take that, times the molar ratio to go from one part of the equation to another. And finish, ladies and gentlemen, reporting out in your final unit. By the way, this problem involves two of the three ways you will be given information. You'll be given the pressure, the volume, and the temperature of a gas, asked to find the number of moles. The number of grams. You might be given grams at the start like the problems that we did. And you may end up having to use PV equals nRT for a gas that is created. You might have to use PV equals nRT at the start and again at the end. Why? Because if they want you to come out in the volume of a gas, they will have to give you the conditions. Okay? So I just want to show you one more problem in our notes, ladies and gentlemen, and then let you have a little bit of time to work on things. Did I show you this problem the other day? Yes? Okay. Then we'll skip it, and I will show you the last problem for these particular ones, which is this. Photosynthesis reaction in green plants use carbon dioxide and water vapor to produce glucose, C6H12O6, and oxygen. Write a balanced chemical equation for the reaction. If a plant takes in 245 milliliters of carbon dioxide at 13.9 psi and 26.3 degrees Celsius, and excess water is available for photosynthesis, determine how many milliliters of oxygen gas the plant would later release if the pressure drops to 13.5 psi at a temperature of 18.7 degrees Celsius. Okay, so you're given two temperatures and two pressures. Why? Why are you given two temperatures and two pressures? Nope. You do PV equals nRT twice. You're going to use PV equals nRT to get into moles, and you're going to report out a volume, milliliters, from PV equals nRT. You are going, just like we did mass to mass, this is now volume to volume. Thank you, Jalen. So let's begin by writing our equation. CO2 plus water produces oxygen, gas, and glucose. Now, when you balance this, ladies and gentlemen, you end up with a 6 in front of the CO2 because then there are 6 carbons here. There are 6 carbons here. There are 12 hydrogens here, so we put a 6 in front of the H2O to get 12 hydrogens here. 12 oxygens here and 6 oxygens here mean there have to be 18 on this side of the equation. There are 6 here already, which means I put a 6 in front here to give you 12. Questions on this? Now, this is the gas we are beginning with. These are the conditions for it. You've got a volume, you've got a pressure, and you've got a temperature. This is the gas we're looking for at the end. We are trying to solve for liters. We have a pressure and we have a temperature. Going to use PV equals nRT twice. So we begin, ladies and gentlemen, with taking what we're given and getting it into moles. Pressure, volume, put into liters. PSI value, temperature, put into Kelvin. Solve for N. N is 0.0094034. That is a small amount, and that is absolutely fine. Now again, ladies and gentlemen, zeros at the beginning are not significant. So this 9 is the first sig fig. I'm carrying a bunch of digits here. Why? Because it's okay to do that. What is our next step in our process, Claire? We've taken what we've given and we've gotten it into moles. So I'm going to take this number, bring it down here, and I'm going to use a molar ratio. What goes on the top of that ratio, Denia? What goes on the top of that ratio? For the molar ratio. Which is what? Which one are you going to? I got a bright orange or bright yellow arrow pointing to it. Okay, so we put 6 oxygen on the top. Now what goes on the bottom here, Madison? Okay, not 1 again. The 6. 6 moles of CO2. So we end up with 6 moles of oxygen on the top, 6 moles of CO2 on the bottom. The 6 here and the 6 here. Questions? Now, I'm not going to kid you. What does this work out to be? 1. But you got to put this step in so you can see that. Okay? Now, normally we would go to what? In our last problems, we've been going to grams because we're through our second step, right? But we don't want to go to grams. What is the final unit of this problem supposed to be? Milliliters, which means I'm going to have to use what again? Okay. Again, PV equals nRT. I can't really put it in as a conversion factor next. So I'm going to solve for this. Now, it didn't change, right? It's the same number because it's a 6-to-6 ratio, but it is a different substance. And now I can put this back into PV equals nRT with these conditions. These conditions. So, the new pressure is 13.5. I do not know what the volume is. That is what I'm solving for. But now I do have the moles. I have the moles of O2. We still have 1.21 as a PSI. As the R value for PSI, I should say. And our temperature has changed. It's now 18.7 degrees. It's no longer 26.3. So we put it in here, but we are doing the same 3 steps. Take what you're given, get it into moles. Use the ratio step. Report out in your final unit. When you do the math here and solve for this, ladies and gentlemen, we get a volume equal to 0.2458 liters. Now let's worry about sig figs, and let's worry about putting it in milliliters. How many sig figs in all those numbers in the problem? 3. So how many sig figs in your answer? 3. So it becomes 246 milliliters. The 5 is the third sig fig. The 8 after says round it up. We converted it to milliliters by multiplying by 1,000. Questions, ladies and gentlemen? Take out your packet real quick. In problems 2 and 3 on the front page, you are beginning with so many grams, and they are asking you to find a volume in liters. But they're telling you it is at what condition? Which means for these 2 problems and these 2 problems alone, how do we get to, or what does STP mean? So that we can use what unit cancellation?
22.4 liters is equal to 1 mole. We do not have to do PV equals nRT in these two problems. You can use 1 mole equals 22.4 liters. So instead of ending up going with formula mass over 1 mole, you are going to end up going with 22.4 liters over 1 mole, only because these are at STP. So you can do those two problems. I guarantee you there's not going to be one on the test on it with STP. If you go to the second page, not the back of the first, but the second page, you cannot do problem 7, but you can do 8 and 9. They are like what we just showed you. If you turn the page after that onto the back of the second page, you can do problems 11 and 12. Now you cannot do the percent yield calculation yet. I haven't shown you how to do that. You actually did that though. You did that in one of your labs. Maybe we did percent error. Percent yield is another type of calculation like that. Don't worry about that. Ignore that where it says then calculate the percent error. You can do almost every one on this packet. Okay, the only one you cannot do is number 7. And we will show you how to do that early next week.
So we're ignoring the extra 11 and 12.
What's that?
You said we're ignoring.
No, I said you can do 11 and 12 except for the part where it says then if so many milliliters were actually produced, calculate the percent yield. Percent yield is an extra calculation we will show you how to do. It's done after everything else is finished. So you could do the problem, ignore that last statement, and solve it. Okay. You got about 5 or 6 minutes, ladies and gentlemen. You could at least get a couple of balanced equations written, or maybe a problem done. Go to work.
1, 2,